Let's go ahead and practice some direct substitution. In our previous video on direct substitution, we used it to find the limit of functions like polynomials, exponentials, and trig functions. We didn't, however, do any practice on rational functions. So let's take a look. In this example, we're asked to find the limit of this rational function. Recall, we said rational functions are continuous everywhere in their domain. Therefore, we just need to prove that 3 is in the domain. Here, we should remember that for rational functions, our goal is to make sure the denominator is not 0. Therefore, we know that x cannot equal 1, so 1 is not in the domain. Great, so if x equals 1 is the only restriction on our domain, 3 would be in the domain, and therefore this function is continuous at 3 because it's in the domain. So let's go ahead and do direct substitution. We plug in 3 for every x, and then we simplify, and we end up with our final answer of 6. In this next example, we're also finding the limit of a rational function, so we follow the same process. We know our denominator cannot equal 0, therefore x cannot equal 3/2. Since x equals 3/2 is our only domain restriction, at -1, this function should be continuous. Therefore, we use direct substitution. We plug in -1 for all x's, we simplify a bit, and then we simplify some more to get our final answer of -3/5. As we saw in all those examples, the domain restriction from our denominator was not equivalent to the x value that our limit was approaching. If it was, we wouldn't be able to do direct substitution right away. So what would we do? We'll cover that in the next video.